determine electric intensity at a point due to infinitely long charge sheet. So let's consider this is the charge sheet where charge Q is deposited uniformly. So charge sheet means here I can consider this as one of the charge sheet which has a two faces, front face as well as back face. So on front face there is a positive Q charge which will be deposited uniformly. At the same time on the back face also the charge Q is deposited uniformly. Now consider there are 2 points. One point is front of sheet P and another point is at the back side of the sheet as a P dash. So there are P point is in front of sheet at a distance R. At same distance there is a P dash point but it will be at the back side. And now you want to find out electric intensity at this P point. So according to our concept, first you have to draw a Gaussian surface. So here I have shown this cylindrical Gaussian surface. This cylindrical Gaussian surface is partly outside the sheet and partly inside the sheet. So on this cross-sectional area ds of your Gaussian surface, your P point lies, and at the another surface area ds, backside surface area ds, there is a P dash point. So P and P dash point both will be at an equidistance point. Now from this positive charge, whatever lines of force will start, it has a direction of electric intensity. This direction of electric intensity and the perpendicular component of ds, both are perpendicular to each other. Means I can say that perpendicular of ds and your direction of electric intensity both are parallel to each other. Therefore, angle between them theta is equal to 0. And hence, I can say that your phi is nothing but, total phi is equal to nothing but integration of E ds cos 0. Cos 0 is 1. So, your phi will be coming as a integration E ds for P point as well as there is another point as a P dash. So for P dash point also I can write down integration E ds P dash point. So this phi I can write down, phi is equal to integration E ds can be written as E into A. A is meaning of integration of ds at point P plus at P dash point also I can write down E into A. So this is I am getting here as a phi is equal to twice E into A. This equation I can call it as equation number 1. At the same time, according to Gauss theorem, we have phi is equal to nothing but Q upon epsilon naught. This is nothing but our equation number 2. So now if we will compare now equation 1 and equation 2, so I can write down here Q upon epsilon naught can be written as twice E into A, where now I am going to substitute value of Q. Now what that value of Q is there? The value of Q is nothing but, here I can say that as Q charge will be deposited on the surface uniformly, so I can write down sigma, that is surface charge density, can be written as deposited charges Q. It is uniformly deposited on area A. So I can write down Q is equal to nothing but sigma into A. So this value of Q I can substitute in this equation. So your equation becomes as, instead of Q I can say sigma A divided by epsilon naught, which is equal to nothing but twice E into A. From both sides your A factor will get cancelled, and now I can write for intensity. So I will get this intensity E can be written as a sigma upon twice epsilon 0. So this is nothing but your electric intensity at a point nearer to infinitely long charge sheet. So during this expression we have used our Gauss theorem. Gauss theorem is nothing but sigma Q upon epsilon naught. At the same time also we have used your total flux. Flux phi is equal to nothing but integration of E into ds. So we have used definition of phi and also we have used the Gauss theorem. And using that two equation we are getting finally intensity E is equal to nothing but sigma upon twice epsilon 0.